Hi, Chandaka.
Hello, Bobby.
So I heard you are going to start a new course.
Yes.
What is that?
I think it will be a very interesting course.
Uh-huh.
It's called Sensors and Applications.
Mm.
Bobby, do you know?
So
Much
it may
about
have a lot of industrial applications.
Yes, I think so. Today we'll do a very brief introduction
Okay.
to sensors
Mm.
and applications. So I think the students will get a nice overview
Uh-huh.
of what the course is going
So
to be.
if I need to select some certain sensor for certain application, I'll be good at it.
Well, hopefully,
And
by the end of this course, you
let's say if I want to design some sensor,
Mhm.
will I be...
I think so, because I think in this course we'll not just look at different types of sensors.
Mhm.
We'll look at how their principle of operation
Okay.
and also how they work.
Oh.
So if you have the resources,
Uh-huh.
you know,
So
if
what you mean then, if I'm good at it, I can...
I think so. I think if you follow the course, right? If you understand the different measurement principles of the different types of sensors,
Mhm.
I think you won't have a problem in doing that. I mean, I know you're smart, Bobby, so I think. Okay, so shall we start?
Yes.
So when we talk about sensors, Bobby, right? I mean, it straddles a lot of different applications,
Uh-huh.
right? So if you look at this here, right?
Oh, so this is automotive, manufacturing, agriculture, wherever. I mean, I cannot see any domain without sensors.
Exactly, right? And many different types as well, right? You can see now, if you really think about it, right? If you look at these different types of sectors,
Mhm.
right?
Mm.
Look at automotive, for example, right?
Yeah.
You see our cars have a lot of different sensors,
Correct.
right? And then if you look at agriculture, right, or environmental monitoring, all these different sectors, right, they have a lot of sensors, right? And
Even medical.
right? So there are lots of different biomedical and medical sensors. If you look at the market in the US, for example, right, it's huge. Medical sensor market is huge. Aviation, again, airplanes, right? You're up in there.
Yeah.
How do you know where you're going, for example?
Correct.
So many different environmental conditions.
So these days it may be difficult to find someone who has never used a sensor.
I think so. I think it's impossible. And I think as we go along in this lecture,
Yeah.
you'll see why.
Yeah.
That exact point.
I got it.
Right? That exact
Yeah.
point. You'll see why.
So usually people get fever. That's what.
Exactly.
Okay.
Exactly. So it's. I think it's. I would say it's an integral part of our lives, really. Sensors.
Mm.
And if you look at the sensor market, right? Here, for example, you can see in 2022, it was a $200 billion market, right? So it's huge. It's massive, right? All these
And
different.
it's doing
And it's growing. So it's got an 8.9%
growth.
Okay. And especially when people are talking about artificial intelligence, IoT, right? Now, artificial intelligence, you're talking about what? Machine learning models.
Yeah.
Where do you think the data is coming from?
Yeah.
Does it fall from the sky?
And without that data, what you will do?
Exactly. Right.
Mm.
So a lot of these technological advancements that we're hearing about today, right? You'll see sensors play a critical role in that. So it's that's why I think it's a very, very important, but also I think hopefully the students will find it interesting as well.
Yeah, right? It was really motivating.
Yeah, and also
on various aspects.
Exactly. Now, if you're an electrical engineer, you're confused what you want to do, what area you want to work in. I mean, sensors, I think, would be a very good field to work in, right? Yes. Okay, so now, Bobby, when I said sensors, what came to your mind?
Yeah, I see the picture. It seems we are the best sensors.
Why are we the best sensors, you think?
See, I mean, skin. I mean, when I touch you, you sense. Tongue. I mean, I think these sensors. I mean, these are natural ones, and the electronic ones. I don't think it will come closer to this.
Really?
I think so.
So, do you think a human being can survive without these sensory organs?
It will be almost impossible, right? I mean, people may be able to survive, but will be very, very hard.
Very, very hard. So I think it's, if you look at our eyes, for example, right?
Yeah.
Eyes get light, somehow convert those image signals for the brain to process, right? And then our ears, can hear. We have, bones and different fluid inside the ear.
Yeah.
That somehow,
even during COVID, I mean, when you miss that smell for a week, you know how difficult it is.
That's why COVID was such a big thing, right? Because people, the sense of smell.
Yes.
So, and, people, there was a lot of cases where people were very depressed because smell means everything, right?
Yeah.
Not just food.
Correct.
You smell people, you smell the environment.
Correct.
Right? You lose that.
Yeah.
Right.
So we are very lucky to have these sensors.
Yeah, very lucky. I mean, most people are, right? We are born with this, inherent capability to somehow sense our environment and navigate the world every day.
Correct.
Nose, we can smell things again, but it was not very nice when you had to put the thing for the COVID exams. Right?
Correct. But some of the, animals are better than us, no?
Yes. So nose is a good example.
Yeah.
So you've probably seen at the airports.
Yes.
You have dogs, right?
Correct.
So in countries like Australia and New Zealand, instead of people, now you have dogs. You have to go through, a section where you have multiple, dogs.
So they smell
a keen sense of smell, right? So they can smell certain chemicals, drugs, and things like that, right? So you're right, yes. So we are not the best when it comes to these sensory organs. But so you also make a key point. But what we can do, you see, all of these different sensory organs, right?
Yeah.
We have different receptors or bones or fluids or something that somehow forms this, whatever you measure from the environment into something that
our brain can.
Yes. We need something also to process this. So it makes sense to us.
Correct.
Right?
Yeah.
So that's a key point there.
Okay.
And again, tongue, taste, right? So that's my next point, is that we receive raw stimuli from the environment, right? And then it translates them into the nervous system, and then nerve signals are then sent to the brain processor, right?
And the brain makes some information out of useful
information out of the signals, right, that the brain receives. And now then we have sight, which is vision.
So you are trying to compare what naturally, we have with electronic sensors.
Yes. So what I'm trying to
going in that direction, or
yes, I think you probably heard of biomimetic sensors, where people are inspired by our sensory organs.
Correct.
And we use that to develop and design. So, for example, we talked about dogs. People are working on electronic noses.
Correct.
Right?
Yeah.
So the main point here is that if you don't know anything about sensors, this is a very nice way to imagine, right?
So electronic nose means there will be some way to probably chemically sense this information, convert into electrical signal, give it to a processor, which, like our brain, gets some information from that and says, okay, this is what you...
Yes.
Okay.
Yes. Somehow you're able to interpret signals that you get from the environment, right? And then you, depending on output, you can make some sort of decision, for example. So that's a very nice way of, I think, thinking of sensors, right? And as we go along, you'll see most of the things we talk about now can be applied to the electronic sensors that you're talking about. I mean, at least the principles.
Yeah.
Right? Yeah. Okay.
Oh, what is this?
What do you see here, Bobby?
Oh, I can see a coil, or it's a heating element.
Heating element, yes. You see a kettle here.
Yeah. So, of course, if I touch, I don't keep my finger long as I'll take out.
Right.
Also, that means I'm sensing that heat.
You're sensing
temperature.
Yeah, you're sensing heat. You know that something is hot. Now, what happens if you have some ice cubes?
It's also similar. It's in the It's cold. Correct.
It's cold.
Yeah.
So your brain is somehow,
Understanding this.
so you have your skin, right? It's sending some signal, and your brain is now saying this is hot and this is cold. Okay. Is that enough? Do you think our sensory organs? So we talked about real world applications. You saw before.
Yeah.
Many real world applications, lot of technological advancements. Do you think our human senses are sufficient for these different types of real world applications? For example,
For this application, yes. Because I know it's hot, I take back the finger.
sure. So you can detect the presence of something or
Yeah.
changes in something.
Yeah.
But what if I ask you the temperature? What's the temperature here?
How many degrees Celsius it is here?
Right? Or
So
Celsius?
that will be the,
Now, if I decrease
yeah.
this,
Yeah.
you might say, oh, it's less hot,
Correct.
right? It can
It's only qualitative feeling that we have. Although we can do some guesswork, but
yes,
I will not be able to say 100 degrees Celsius or
yes. I think you
Sure.
probably will be able to with a large error,
yeah.
right?
Yeah.
So I think that's the limitation maybe of our sensory organs. We don't have that, I think, at least inherent capability to say this is exactly
Yeah.
21.5 degrees Celsius, for example.
And for us, it may not be required also.
That's right. That's a very good point you make, right? Because we are all about survival.
Yeah.
Right? We need our sensory organs to survive. Correct. So here, you're trying not to get burnt,
Yes.
right? That's all that matters.
And inside us, probably it is accurately measuring because our temperature is kept 37
Exactly.
degrees Celsius.
That's right.
So somehow there is a way to measure and
That's right.
maintain this.
That's right.
So that is there.
Yes.
Only thing is, we ourselves are unable to say how much it is.
Yes. That's correct.
Mm.
Yes. So that's a good point, right? So I mean, I think that even the human body has its own kind of control system.
Correct.
Right?
Correct.
But we might not be able to somehow,
Yeah.
because we don't really use it.
Right? It's running automatically.
Yes, so it's pretty perfect with human
Yes.
being, right? Okay. What do you have here, Bobby?
Oh, some yellow thing.
I see a few yellow
wires going to that. Is it a motor or something?
It's a motor.
What are we going to do with this?
Now, what happens normally? Motors are used for so many different types of things,
maybe
right?
to connect it to a pump and pump the water or run a load or
Exactly.
yeah.
And normally we give it a certain current, right? And it
Yeah.
runs at a certain RPM.
It maybe keep running
Keep running. Okay.
in a factory, for example.
But what will happen, for example, if I increase the current?
Uh-huh.
Or let's say you said it's connected to a pump or something.
Yeah.
Right.
Some load.
Some load.
You increase the load suddenly.
Or increase the load. Or there's
Some fault in the motor.
fault in the motor. Or let's say, all these motors are kept in a room and, someone's supposed to open the windows. Someone keeps it closed.
So there is no air circulation.
Then what's going to happen?
Slowly this guy will be getting heated.
Exactly. Right. So this will get hot.
Okay.
Now,
And then slowly this insulation will get damaged and then fumes will come out.
yes, now there'll be a big problem.
Yeah.
Especially if you have multiple motors.
Yeah.
Can you ask someone?
You wanted to sense this.
Yes. I mean, let's say there's a human being, right? There's some worker,
Yeah.
right?
Yeah.
We
you
ask
can
him
stand
to-
always and sense.
Or we can ask him to go every 30 minutes. He knows what the reference, how hot it is. It's a
But
reference.
that's not something scalable in the industry.
It's not scalable.
Yeah.
You can't keep doing that.
Yeah. Also, I mean, if there is a change in temperature or if there is some fault, I would like to detect as early as possible so that I can do some action.
Yes. So you're saying somehow,
I wanted to monitor the condition of the motor.
so you want to have something, for example, right?
Yeah. That gives me the temperature.
Some, let's say, sensing element
Yeah.
that measures temperature.
Yeah. So I may also be interested in, for example, vibration.
Vibration.
I mean, if there is a fault or
Some misalignment.
things
right?
like that, I may be able to pick up early and then make some maintenance action.
Right. So that could also make, or could make it warmer.
Yeah.
And as you said, these kind of motors are for maintained over a period of time, right?
Yeah.
So maybe every 2 years or something.
Correct.
Right. But imagine you have some sort of a sensor, right, that measures its vibration.
Correct.
And this vibration could be linked to the failure of the motor.
Yeah.
Okay. But let's say now you have another sensing element.
Some way to sense that.
Some way to sense that. Now you have some,
Let's say,
the vibration.
accelerometer.
Right? And let's say the normal vibration is supposed to be at a certain threshold, but now you see it increasing. So now there's a problem with the motor when it comes to, for example, could be a misalignment.
So you are coming up with ways of electronically recording the healthiness of the motor. Nice. Using sensors.
Perfect, right? So that's, I think, one way to look at why we need
Sensors.
right? Other than the sensors we have in the human body.
Yeah.
Okay. So Bobby, what do we have here? What is this?
So I see something called measuring sensor processing system, unit, output, input. Oh, what is this?
So
Measurement.
what is measurement? Measurement.
I know measurement.
Measurement is
Process of measuring something.
yes. What are you measuring?
Oh, so like this temperature, if I'm measuring temperature, then temperature is the measure.
Oh. Right. So it could be a physical quantity.
Mm-hmm.
Okay. Or some sort of a measurement variable. Something that varies.
That you are interested in monitoring.
Yes.
For example, the vibration that we mentioned in the previous slide.
Right.
That could be a measure.
That could be a measurement.
Okay. So that is given as an input to the sensor.
Input to the sensor. Now this can come from something like a motor, or it could come from the environment. Like temperature, for example, can come from motor, can also come from the environment, right? If you're measuring environmental conditions.
Yeah.
Right. Still, you need some sort of a sensing element.
Okay.
Okay.
Can you give one example?
The easiest example of a sensing element, let's say measuring a temperature sensor, for example.
Okay. So temperature, how do we sense?
Oh, there are different kinds of ways that measure temperature, and that's a good point you make.
Mm.
So before getting to that, why do we need this processing?
What is this processing?
Exactly. So if the sensor is measuring an input, why can't it just output?
Yeah.
Why do we have to process?
I'm getting confused. Measurement is somewhat clear.
Mm.
You have given that input, or the sensor is exposed to that measurement now.
Yes.
So temperature, if that's the one, the sensor is in that environment where you want to measure temperature.
Right.
But
So then,
what is that sensor? I'm not able to.
now when we talked about
Skin, I understand. I touch. So that means here the sensing element is the skin.
sensing element, is
Skin and the nerves and so on.
exactly, right? So it has to travel, and then you have your brain that
To
processes this nerve signals. Otherwise, it wouldn't make any sense to you, right? Right? So your brain is basically saying it's hot, it's bad for you.
Mm-hmm.
Now here we have a processing or system unit that takes whatever value.
So now this process that we said, it has to be done electronically.
Now this process has to be somehow done electronically. And then you have an output, right? Now if you're observing this output, okay, you'll see some value here.
Okay.
And by looking at that value, you should be able to somehow link that value to what you're measuring.
Okay.
Okay.
So if it is temperature, can I measure using... See, I know, for example, if you take a resistor, it's a resistance of a piece of rod,
Right.
conductive material. It's some rho L by A.
Right.
Rho is this conductivity.
Mm-hmm.
So when we, change the temperature,
Yes.
I think this rho is the resistivity.
Resistivity, yeah.
Not conductivity.
Yeah.
So the rho changes with respect to temperature, correct?
Okay. Yeah.
There will also be some dimensional change.
Yes.
So L and A also may change.
Yes.
But effectively, there will be a change in resistance with respect to temperature.
Yes.
Can I use that as a sensing element?
Why not?
to
Because
sense temperature.
yes. Because why? Why can you use it? Because you have a measurement, a variable.
Yeah.
Your sensing element is changing somehow
According
to the change in that measurement.
measurement.
Oh, yes, exactly.
Okay.
Right. So in that case, you should be able to use something like that to measure temperature.
So now that change in resistance, I need to somehow measure and then say, okay, this is 30 degrees.
Exactly. So for
That is
example,
what this processing unit is doing.
yes. So exactly. So if I give you a certain resistance value, that will not make much sense.
Correct.
Right? You must feed that information to this processing system unit, and then that will convert it to something that makes sense to the observer. Okay. So that's a
Got
basic,
some idea.
right?
Yeah.
But you see, the key point here though is the sensing element, right? Because without this, right, you won't be able to really measure anything.
Yes.
Right.
Yes.
So the sensor, you can see, plays a key part, and we will see as we go along how important sensors are. That's why I said it's not just interesting, but also I think a very important course for the students to learn. And as you said, we all come across sensors every day in our lives, right? Okay. So Bobby, sorry, let me actually, so the output, we didn't talk about the output. So the output, right? What output can be a voltage, a current, some sort of electrical signal.
Yeah.
Right? That corresponds to what you're measuring. Or it could be a non-electrical signal. Right?
Could be. But in general, I see electrical output.
In general, you're correct.
Because I may need to record it, save it for, or process further. So usually an electrical output.
Yes.
But it need not be.
It need not be. So I'm gonna ask you, can you give me an example of that?
Since you're shown, I have that.
Because I'm using temperature because temperature is, I think, a good example to use when you talk about sensors, at least in the beginning.
Yeah.
So I'm going to ask you, you saw
Thermometer,
right?
Yeah.
So here you saw, I remember when you were kids, if you went to the doctor,
correct,
right? He would take this, put this under your tongue, measure the temperature.
Yeah.
Okay. But here I don't see any electronics.
Oh, that's true.
Right? There are no electronics. There's a scale.
Yeah.
Right? Scale here. There's a scale here. And there's something here.
Mercury there.
Yeah. So there's some input, right? You're actually now measuring temperature of your body.
Also, there is some expansion of that liquid.
Right.
Okay.
Exactly. So there's mercury here, right? That contracts and expands according to
The temperature.
Here, there are no electronics. Right? There's no need to power this. It all depends on the mercury contracting and expanding according to the temperature. Now, obviously
So this is also a sensor.
This is also a sensor, right? It's giving you a non-electrical output.
Yeah.
But we know that we don't use mercury thermometers anymore because mercury is
not that good.
It's right, toxic. But so we also talked about an electrical kind of output.
Yeah.
What's here?
So for me, it looks like a multimeter.
Yeah. So multimeter, and you have some
Display.
output here, display there.
Yeah.
They're telling you.
What is this white wire coming up?
And it's
a
connected.
blue tip.
Exactly. It's connected to something here.
Hmm.
And here, if you look closely, you can see this is temperature.
Okay.
So if this is temperature, what do you think this is connected to? It's measuring temperature.
Yeah. It could be some resistive temperature element, but I don't know what element it is.
Right. But it is measuring temperature. Right. So here.
It could be something like I mentioned earlier.
Yes.
Change in resistance with respect to
Exactly. Thermistor or thermocouple, for example.
Right.
So this is another way that temperature can be measured. I mean, this is a very easy example. You have a multimeter that you use in the lab.
Thermocouple means what?
Thermocouple is you have two joints.
Two different materials.
Two different materials and
joined
together. And you have this Seebeck.
There is some effect.
Seebeck effect, I think. From that, you can measure the temperature.
So it generates some voltage depending on the
the difference
in the temperature
in the temperature in the two, because the two wires are different temperatures.
I think it forms some two junctions. One junction is at some known temperature. The other one is exposed to what you want to measure.
So like a reference.
So you get a voltage with respect to temperature. Yes. So it is generating by itself.
Yes.
It's a self-generating.
It's a self-generating
sensor. Yes. So it could be that.
It could be that. But the key point here is...
Find out that, but yes.
Yeah. The key point here is that it could be non-electrical. The output of a sensor can be non-electrical or somehow electrical based. Okay. So what do we have here now, Bobby?
Your number of blocks are increasing.
Exactly, right? So, I mean, before we just had the measurement, input and the output, right?
Yeah.
But now we have amplifier and ATD converter, computer. What are we doing to the sense signal now? I mean, and why do we need to do this? For example, I mean, you're doing some sort of a, I would say, signal conditioning here.
What do you mean by signal conditioning?
And signal maybe processing here. And what is this A to D converter? And then you're feeding it to a computer. I mean, are we making things complicated here? Why can't we stick to something like mercury thermometer? Why can't we just use, for example, a multimeter? I mean, it's simple enough, right? You're still measuring temperature. Why do we need to do this? All this?
Maybe this will make it more usable, depending on the application. If you want to just measure once, the previous one that you showed may be enough.
Right.
But if you want to record continuously, maybe change in temperature in a furnace, you wanted to monitor and do some action based on that. So probably I need continuous output.
Right. And if you want continuous outputs and you also want to do some operations, right? Some, let's say, pre kind of processing and after.
So you get the signal and then you do some digital signal processing.
Yes. Let's
say
that's
why you have a computer there.
Yes. Right. So, let's look at the first block here, like the single amplifier. Yeah. Now, we talked about temperature. Fine. Let's think about some other measurement. Let's say that measurement is very, very small. Or let's say you want to measure the temperature, but you want to measure a very small difference in the temperature. Okay.
0.1 degree change.
0.1 degree change. And let's say that's important for your application, right? In that case, if the signal is very small, right, we might not be able to really see that signal, right? There could be some other
so you want to amplify that.
Somehow amplify that signal. Okay. So you're now basically playing with the measurement, right? You're amplifying it now. Okay.
So the output from the sensing element. For example, if it was a thermocouple, it may be some millivolts.
Yes.
Depending on the temperature,
and
material selected, etc.
Yes.
And you are going to give it to an analog to digital converter.
Correct.
And that analog to digital converter also has some input range, I think.
Yes.
let's say 0 to 5 volt.
Yes, exactly. So this has a 0, let's say plus 5 volts.
Yeah.
Right?
So if I give 1 millivolt to this ADC and then digitize, what I get maybe just noise.
Right. And if you get, let's say there's a change in the temperature, you get the same signal again. You will not be able to distinguish.
Yes. Unless otherwise I use a super ADC with so much of resolution.
But now we are complicating things. Correct. But let me ask you before that. That is true.
So in that case, if you can amplify and then digitize,
that will make a lot of sense.
It's better.
Yes.
Or the error introduced by the ADC will be small there.
Yes.
Less there.
Yes. My next question, Bobby, is fine. Now we understand why we would want to manipulate the signal. For example, by amplifying it. Why do we need an A to D converter? Why do we?
True.
Let's say you get an analog signal that's
Yeah.
constantly changing over time.
Yeah.
Okay. Now you want to change it to a digital signal. Again, we'll talk about the difference a bit later. But A to D converter is basically you take an analog signal and change it into a discrete digital signal.
Yeah. Gives out a digital output.
Right. But why do you need a digital output? Why can't we just go from here to here?
I think computer doesn't accept the analog signal.
Exactly.
Yeah.
Right. So again, let's say your computer is the brain now.
Yeah.
Right.
And you have to somehow feed it.
Somehow feed it. If you're going to feed it something that doesn't.
It talks only digitally. So you change the signal to digital. And then keep. Okay. Exactly.
And then in the computer, now you talked about digital signal. Now in the computer, your signal, whatever you're measuring here, right? What you're measuring here, this input, okay, is now a digital signal.
Yeah.
Now in the computer, you can further manipulate this signal, right? You can do further processing because now you have your digital signals, you have a computer, right? You can do all sorts of operations on this, depending again on
the application. AI algorithms that you mentioned can be there in the processor if there is a need.
Exactly. Yeah. Algorithms, and as you said, if it's driving something, right? If it's driving a load could be anything. Depending on that, you can do further processing in the computer.
So that's the brain.
That is the brain.
With your earlier analogy.
Right. But according to the earlier analogy, the signals you send should also make sense. So what I'm trying to say is, if you get a sensor and you send a signal straight to here, it might not work.
Correct.
Okay. For various reasons. We talked about amplification. We talked about the HD converter.
Yeah.
So you need some sort of conditioning and processing.
Yeah.
Right. Before you send it to the computer.
Yeah.
Right. So sensors. So you can think of the whole thing as probably like a measurement system. So, and now, nowadays.
So in a typical sensor unit, all this could be there.
I think in most
Yeah.
sensors, right? Sensing, let's say measurement systems based on sensors.
Yeah.
I think these are some of the things
Standard.
that you commonly find.
Yeah. Sometimes it could be amplifier and a filter and
exactly.
So on. Yeah.
Sometimes it could be a filter, right?
Yeah.
Right. Now, nowadays you also have all these different kinds of boards, right? Like Arduino, Raspberry Pi.
Correct.
Right. So
those platforms.
So this computer can also be, let's say, for example, here you have an Arduino. Okay. You can have a sensor that is now some of these platforms is a good word to use, really, because why is it a good word to use? Because most of these platforms now have a lot of...
it has got these modules inside.
Okay. Like I remember, when I was doing my bachelor's, right? We had separate components, right? We didn't have the luxury of something like Arduino. But here, sometimes these Arduinos, in fact, have integrated temperature sensors.
Yeah.
Right? So what you see here, right? You can see something like this.
Mm-hmm.
So you can have here. So for example, here you have an external temperature sensor here. Here's your temperature sensor. Okay. And then somehow there's some conditioning and some A to D conversion going on here. Okay. And then you have your output, which you can see in the CD screen.
Or we can get it to the computer also. Yeah.
Exactly.
So this is one of the standards platform where we can do certain laboratory level activity.
laboratory level activities, right? Some
It may not
experiments.
be best to use in an industry. But
No.
it's not designed to.
Yes. Yes. So you're talking about industry. You'll see that we talked about this mercury thermometer, right?
Correct.
Very simple kind of thermometer.
Yes.
But you also have these kind of,
Yeah, this one I know.
Right?
Yeah, I've been using one.
again during COVID time, right?
Yes.
A very important sensing tool. But what do you see here, though? What do you see here? I mean, compared to here, and take into account what we just talked about. What do you see here, though, in this kind of systems?
Yeah, these somehow senses the temperature and displays a digital output.
Right. So there's things going on inside this.
So those blocks that you showed in the previous slide are there inside this.
Right. There has to be some sort of
Realization of that somehow.
that inside. And for the user, right, you go out and buy a temperature sensor.
Yeah.
And all you have to do, for example, if it's infrared, you point it, put this in under your tongue, or you'll get an output. You see temperature, right? But inside there's a lot of electronics going on. But the key part again here is the sensing element, right? Because that's the key point. That's where you start. That's your data
Is initiated or
generated.
But then the electronics is also important.
Electronics is also important.
Because that somehow helps you to derive the best from that sensing element.
That's true.
Yeah.
But let me ask you a question. What's more important, the sensor or the electronics?
I think both are important.
Both are important.
Yes.
So can you have, let's say, a sensor that's, let's say, not very sensitive, but you have the best electronics?
No use.
No use.
Vice versa also.
Vice Right.
Because they are anyway in series.
Right.
So if one is dumb, the final output will be of no use.
So when you're talking about sensors, you also have to think about the whole measurement system.
Yeah.
Okay. Now I keep increasing the.
You have one more block now.
I have another block here, right? Now all these things we talked about before. Now you have the computer. We said with the computer, what did we say? We can do further manipulation.
Correct.
Right? Do more processing, digital processing. And now we have something called an actuator, which is the last. Because after that, there's nothing.
Oh, I'm happy.
Right? You have the output. So before all this time, we were talking about observing the output.
Yeah.
Right?
Recording it.
Recording it, displaying it, saying it, oh, this is the temperature. But now
what you do with that temperature.
Exactly.
Yeah.
Right? What do you do with that data?
So if it's an air-conditioned room, what is this actuator?
Yeah. What does an actuator do? And for me, when I think about actuator, I also think somehow it has to be actuated, right? So it can. So in my mind, I imagine it an actuator to somehow perform a task based on the sensor output.
This air conditioner is easy for me to relate to because I see it regularly. So I set 27 degrees and then I'm happily sitting on it. So how is this? So there, what will be the actuator? There will be a temperature sensor.
Yeah,
that
the
measures
actuator is the
maybe the air conditioner.
Air conditioner itself, and of course, maybe it needs more current or something if you decrease the temperature, things like that. But what if I show you this diagram? What does that tell you?
So temperature sensor detects the heat.
Now this could be anything, right? So this could be, let's take an example. Okay, let's say that this temperature sensor is in a room. Okay, and somehow the room gets really, really hot, right?
Yeah,
it's much higher than what it should be. Okay,
it's like Chennai weather.
It's like Chennai weather, but let's say worse, right? So you can imagine. Now, sensor, what does what do sensors do? They send signals to some control center, right? Which is, let's say, your computer.
Yeah.
Is your control sensor. Right?
Mhm.
This is the same thing. Now, because it's too hot, normally, if let's say a room gets extremely hot, maybe there's a fire in the room.
Mm.
Now, of course, gases are also something that, now in smoke alarms,
Yeah.
and they have temperature and gas sensors. But now, if this temperature sensor only just measures, I don't know,
And then records.
and then records,
Just a record of what has happened. Yeah.
is that useful?
Not.
And that could be
Yeah.
could be fatal, right?
Correct.
Situation like this. So
So you need to do some action.
there's no action. Now, let's say this is connected to some switch,
Okay.
on off. Very simple.
It can be a relay
It can be relay.
that turns on, makes a contact and maybe enable current flow.
Exactly.
Okay.
Right. So if there's a temperature and then suddenly it's going really high, right? This is turned on.
Okay.
And that is in turn connected to a sprinkler system.
Or it sprays water.
It sprays water.
Nice.
Automatically turns on, sprays water. Somehow
Avoid the fire.
avoid or deals with the fire to at least, maybe probably wouldn't put out the whole fire, but at least will kind of limit the damage. Okay. So here's an example where we have this, but the output is somehow fed into what is called an actuator, which performs a certain action. Now you see sensors are, are becoming, very, very
More meaningful.
more meaningful, and you can see how useful they are
Yes.
in real world applications compared to just looking at some value. Now, this is just on and off.
I was just thinking, you have shown one motor earlier. So if I want to maintain the speed at which the motor is rotating at some specific speed, I could do something like this.
Exactly.
Use a sensor, monitor its
RPM.
RPM. RPM means revolutions per minute. Okay. So let's say 1500 RPM. So I monitor that, give that feedback to the motor somehow. If it is less, increase input or reduce input and maintain that.
That RPM.
That is some.
Yes. Feedback. That's a good point. Feedback. What is this feedback? I mean, I don't see any feedback.
They used to get student feedback.
I mean, so you're saying somehow this is again connected to this? Sorry. You're saying this is somehow connected to here again?
Not to the sensor.
Where will you connect it? Then.
So no.
Then where will you connect it?
There should be some module that. So I think in this case, it may go to the controller. I mean, you have already connected, maybe.
But then here you're turning it on and off.
Yes. It's an on-off control.
So then when the sprinklers are on, let's say the temperature
comes down.
And then
It's off.
it's off.
Yeah.
So then somehow, again, this should send another signal.
If temperature goes up,
Turn on.
yeah, I mean, sensor will be always monitoring,
Yes.
but the actuator will get turned on only after reaching some threshold of temperature.
Right. So when the temperature goes down, then somehow
It has to turn off that relay.
Right.
So that will be an on-off control.
that is on off, right? But RPM
On-off may not be sufficient. We may have to do better control.
Right.
So maybe we need a better block diagram to convey
Right.
that. Got the point. Yeah.
What is this? Ooh. You talked about feedback and control, and because you mentioned those two words quite a bit before.
What is this reference while you?
I don't know. I mean, all I know is there's a sensor here, right? Measuring the temperature.
Okay. So then the reference will be like this 27 I have kept. 27 degrees, let's say.
Let's say 27 degrees Celsius. Okay. And then you have a heater. Or let's say AC.
Air conditioner.
Air conditioner. Yeah, air conditioner.
It could be heating or cooling down.
Yeah.
So there is some action based on that error signal that you have shown.
Yeah, so the heater is
don't
in
know
the,
what is error
so the
signal.
heater heats the room, or
Yeah.
for example, let's say it's winter and you want the room heated.
Yeah.
Just for the sake of this example, right? Then
TA is the actual temperature.
actual temperature. So that's the temperature in the room.
So that is, you are sensing that.
We are sensing the room temperature, and we are now sending the room temperature into something here, right?
Oh.
TA. We also have a reference value here.
Oh. Now, when you are taking difference of these two,
Yes.
ideally they should be equal.
Yes. So now if this is 27, then do you think there needs to be any action taken?
No, everything fine. We can see.
But then if this goes up to 30,
then there will be an error signal.
and then what happens?
That will do.
Now there will be an
break
error.
up the heater to heat or cool down. So this is the feedback you are talking.
Okay, feedback loop that you avoid. I mean, with the motor RPM also, I think this is something that could be used to explain that too, right? But you take this out,
Then it is open loop.
it's open loop, right?
Yeah.
That you cannot
I have
accurately control.
I have a question.
Yes.
So let's say I want to maintain this 27.0 degree.
Okay. In the room.
Yeah.
Mm-hmm.
You have mentioned about this feedback and so on. I bought a very low cost sensor.
Okay. Sensor here.
Yeah. The sensor you have mentioned. I purchased a sensor. Its accuracy is, it measures and gives something. I think it changes 2-3 degrees. Error is quite large.
Error is 2 degrees. So
Yeah.
plus or minus
Plus or minus 2 degrees.
2 degrees.
Because I saved some money there. So, can I ensure that I will get something, 27.0 degrees?
Now, if you're saying the error is 2 degrees Celsius,
Yeah,
that's quite high.
correct.
So in that case, I don't think.
Yeah.
27 degrees. It's good.
That to 27.0. That means 27.1, 0.2 like
Yeah.
that.
Exactly. And you also forget,
Yeah,
right? The heat has to act,
correct.
and that could also
Yeah.
take time, right?
Yeah.
To make sure that the temperature is kept at that. So
So, let's say I have put a lot of money to buy, the best heater I have. You give the error signal, in 1 second it makes the room.
okay.
So I put a lot of money, but I saved in this sensor. Is it a good idea or a bad idea?
I think it's a bad idea. Because what's the point?
Yeah.
Because what you're measuring with
Yeah.
the sensor, that sensor has a large error.
Yeah.
So no matter how good your heater is,
Yes.
that wouldn't make
The
any difference.
room temperature, if you want to maintain so accurate, it's never possible with this sensor I purchased.
Exactly. So it's in that case, it's better for you to buy a jacket. So you make a good point, Bob.
Yeah. So this means this overall system performance cannot be better than the performance of the sensor.
Never. I don't think it can be.
Mm.
Right? Now, let's say this you have something that's 0.1.
Yeah.
Then you might get close to this.
Close to it. Yeah.
Right?
Yeah. Now, another aspect, let's say 0.1 degree accurate, but it takes couple of, 10 minutes to settle to that value. Then also there is a problem.
Then also there's a problem.
So it may have to be fast enough for
Yes, the fast response.
Yeah. So when we say performance, it's not just accuracy, there are more parameters to look into.
Absolutely. Fast response. Not only that, let's say it's also only measuring every 5 minutes. The sensor is only able to measure every 5 minutes.
If it is like that.
Yeah.
Hmm.
Then, is that also a problem?
Then
Will this all be 27 degrees?
it get set to that 27 degrees every 5 minutes. In between, it's
So this could go up or down.
Yeah.
During those 5 minutes. Yeah. So as you said, there are other things that we need to consider.
Yeah.
Right. Yeah. When you talk about sensor, it's not just how accurate it is, the response, and how often the values are taken.
Yeah. But the sensor plays a crucial role. Yes, that's very clear.
Yes, because without a sensor, there's no way you can do any of this.
Yeah.
Right. Okay. Right. Okay. So Bobby, we talked about, this is the basic. I know you don't like all the rap, so let's get back to the.
Also, you made a short. Nice, thank you.
We talked about this measure, right?
Yeah.
Physical variables, environmental variables. What are they? I mean, because we have
mentioned about temperature, speed. I mean RPM, but there are
vibration,
vibration,
right? But I mean, okay. I mean, for that you only need a certain number of sensors, right?
Yes.
You don't need a variety of sensors.
Yeah.
Why do you think we need? What do you have here?
Also, a lot of things.
Right? So this measurement, whatever you're measuring, right?
It's like the human sensors that you mentioned earlier.
Exactly.
Vision, temperature, taste, smell.
Yeah, I mean, even
touch.
Even within taste.
Yeah.
We can say it's salty or sweet or even hot or cold. Right?
Yeah.
So if you're talking about electronic sensor,
with a single sensor, we are able to selectively say, okay.
Exactly. Right. This is sweet. This is salt. We can eat a sweet thing, salty thing, and we can say which is which, right?
Unbelievable.
But in the real world,
right?
Especially if you're talking about the environment, there are lots of different energy forms.
Okay.
So here I've only shown some basic ones, right? But biochemical, electric, magnetic, acoustic, mechanical, optical, thermal, right? And each of them, right, have different kind of things that vary.
Okay.
Right. So temperature is temperature, right? But let's say if you take biochemical, some chemical.
Oh, the composition, concentration,
pH,
right? Reaction rate,
right? If you talk about electric fields, conductivity, permittivity, different types of magnetic fields, permeabilities of materials, acoustic waves, mechanical waves. These things, for example, lots of different things, and they all fall under mechanical energy waveforms, right? And then you have your optical sensors, your thermal sensors. So this is just one thing we talked about, right? Temperature. But if you talk about thermal, there's flux, specific heat, thermal conductivity. So these measurements, there are a lot of different measurements in the environment that we have to measure.
Yeah.
For so many different applications.
Yeah. Now I am able to relate to the second slide that you're shown.
Right.
With the sensors in multiple areas.
The real world applications of the sensors, right? And also the technical advancements, right? Within those sectors, right? We are not measuring the same things we measured 10, 15, 20 years ago, right? We sometimes find something new that we want to measure.
Yeah. There is some saying, no, if you cannot measure, you cannot improve it.
Well, this is true, right?
Yeah.
This is true. It's a good point. You said it like a song.
Yeah.
But yeah, so before we only talk about, measurement being some kind of physical quantity, but you can see it encompasses a whole, wide range of things we can measure. Now, when we measure things, so Bobby, let me ask you, we talked about temperature, right?
Yeah.
And we even showed some different devices that you measure temperature. If I give you a sensor, now you want to measure the temperature of this room, and that device says 40. What does that mean to you?
If it's just a number, I may guess it because we know it.
Yeah.
Degrees Celsius or something. But just a number doesn't mean anything.
Just a number doesn't mean anything.
Yeah.
Right? If a sensor outputs a number.
Yeah, it's like when you say, what's your weight? 75 kg. You say, oh, that kg came automatically. But it's just 75.
Yeah.
Of course, we have some idea.
Yeah, but that's not the point, right?
Yeah.
Especially if you're using it in an industrial setting.
Yeah.
And you want to make sense of that.
Yeah. You are sending this data to somewhere.
Right? So whatever
it is processed, it will be used by somebody else.
Right? And is probably applied to an equation, for example.
Correct.
Then it has to make sense, right? So
The unit is a key.
unit is the key. Okay. Right. So here, again, we've only shown
Or
you.
you start with mass, kilogram.
Yeah. So you said 75 kilograms.
Yes.
But these are what are called SI units, standard units, that are used in most countries. Now, there are countries that
This is some internationally accepted.
accepted standard, right?
Yes.
Some way to standardize your measurements.
So the 1 kg here and 1 kg in the plants, it should be same.
Right?
Otherwise, it's a problem. Yeah.
Right.
Yeah.
So, I mean, again, here I've just used, shown some quantities here.
Temperature.
Speed, velocity, acceleration, magnetic field. So they all have an SI unit. Kind of a standardized way for someone reading those values, or some control center or some actuator will understand what what the unit is of that value.
Yeah.
Otherwise, it will just be a number.
Correct.
It might not make any sense, right? So that's another important thing when you talk about sensors. Whatever sensor you're using, right, should always also come with a unit.
Yes.
Okay.
Same with writing answers. When you solve and get
Yes. So that's for the students, right?
finally write the answer without unit.
How do you know
Yeah.
what is what, right?
Yeah. Sometimes teachers will dish. Very strict teachers.
Right.
Yeah.
Yeah. So that's another important thing that I think to consider when you talk about sensors. So, Bobby,
Oh, it's very nice.
people are talking a lot about artificial intelligence, AI,
Yeah.
machine learning, right? All these different things now, and IoT, the Internet of Things, where generally you have sensors, and then you can wirelessly communicate, for example, to, let's say, a computer or some control center. And mostly now, most of these sensors are connected together over the internet. And then you perform some data analytics, right? So that, for example, you talked about the motor, so you can predict when it's going to fail, which means you can predict the maintenance before it fails.
So I can do predictive maintenance.
You can do predictive maintenance, right? And also, that information can be not only fed to a motor or something. It could be any kind of assembly line. It could be any kind of actuator. It could be shown in a visual data board, but all over the internet, which also means that you can connect a whole variety of sensors in different locations, right? If you're looking at, an application that requires you to understand how measurements kind of change over, different areas in the world, for example. But the key point here is, again, what do you see here? I mean, from this workflow diagram, what do you see? I mean, what kind of what's the normally, especially in our part of the world, we talk about hierarchy, right? As a top guy, right, kind of trickles down to the guy at the bottom, or the person at the bottom. If you look at this workflow, where does it start?
It starts with the sensor. That's what the diagram shows.
It starts at the sensor, right?
Yeah.
So, but then, but people always talk about data analysis and machine learning and things like that. They have to get the data from somewhere,
Correct.
right? So, is it fair to say all the things that are happening here, all the nice fancy things that are happening here, that sensors are the data source? Now, in the previous example, when it comes to the heat and the room, you said you bought a cheap sensor.
A low cost one. Yeah.
Low cost one. Okay. Now, in the in the computer science world, there's a term called GIGO. You know what GIGO is?
Garbage or something.
Something to do with garbage, yes.
Yeah.
Garbage in, garbage out. Okay, which means that poor quality data as the input will result in poor quality output. So if your sensors don't give you
The required accuracy and performance,
accurate, reliable data,
your decision will also be like that.
your decision must be like that at the end of the day, right? So, however way you look at this, right? Now we looked at several block diagrams before.
Correct.
Now we are looking at things that are happening now.
Yeah.
Technological
Very,
advancements.
very modern.
Very modern, right?
Yeah.
Very modern.
Because your sensor, that is, data is sent wirelessly or through the internet.
Yeah, I mean, exactly.
Then,
If you look at these
Yeah.
separately, these are all,
Yeah.
massive advancements, right?
Yes, yes.
Sensors have been around for a long time.
Correct.
But
These advancements only improve the use of sensor.
yes,
Right.
Yes. But at the end of the day, this is the data source. This is
Correct.
the core.
Correct.
Right? So it plays an integral part in the whole kind of workflow.
Mm.
Right? So, I mean, you made a good point before. And it was a very simple example, right? You're talking about AC.
Yeah.
Right? And you said, I told you, it can never be better than the sensor you choose. Right?
Correct.
Similar example here, right?
Yes.
Even though this is a much more kind of advanced look at the role of sensors, but still. So it's a very important aspect of. So, I mean, just to give you an example, Bobby.
Yeah.
What do you see here? You see a room here, right?
I see a room. I see some kind of home.
Yeah.
Internet.
You see an AC here, phone, right?
Many things. Yeah.
You see an AC here. You see a fire here.
Yeah.
Okay. Now, before we talked about an example. What do you talk about? We said if the temperature increases,
Correct.
the information goes
In the water, something.
in the water. That is fantastic, right? But what if the fire is out of control?
True.
Right? Now, what would you do in a situation like that? You would pick up the phone,
Yeah. Call
immediately, right? Wait, and then they would ask, "Where are you?" You give the address, right? So, now imagine a situation where you have a couple of sensors. Let's say a temperature sensor and a camera. Now, camera, some people might say it's not a sensor, but it provides you information at the end of the day, right?
It's a sensor.
It's a sensor, right? Maybe not in the technical aspects, but somehow. So let's say now there's a fire. Your temperature is going up, right? Your camera can also now get a video of what's happening
Yes.
in real time. Now, all these sensors I told you before in the Internet of Things is connected to the internet. Okay. Now it sends information to the internet.
Okay.
This is the cloud. People are talking about cloud these days, right? Cloud has a certain database. Okay. Could have certain machine learning programs, right? So this information is sent to the cloud. And from that, automatically, an alert is sent to a fire engine. Right.
So when you say cloud, what is this? It's is it the cloud
Cloud is
that I see? Or?
no. Cloud is let's say it's a server or servers that are connected to the internet, and all these different types of sensors are connected to let's say a virtual location.
Okay. So it's a place where the data is stored, and you can also do some processing.
So it's basically stored on the internet, right? Okay, somehow. So otherwise, you will have to have servers, for example, locally, right? Which is not ideal. Right? Automatically sends an alert, and then it sends you an alert if this is your house, right? It gives you a picture of what's going to happening, and for the fire station, it automatically sends the location. Right? So this fire station, you don't have to call and say, "I'm here, I'm there," or already know what's happening. It will go here, right? So
quite smart way of handling this.
Smart way, but and also an automated way, right?
Yes.
Right. Your role is very limited in here, right? You know what's happening, right? So you could rush home.
Yeah.
But a lot of things, and again, let's say there's no camera. Let's say there's no temperature, right? Then again, all this, and let's say, as you said, you have a really bad temperature.
Yeah. Once in a while, it will generate, oh, there is fire there. Wake up, everybody. Just goes to the cloud. Fine.
Exactly. No problem, right? Right? So you can see now why. So that earlier point you made, now you can see, right? It follows in every single example that we use since. You can see that, right? Why the quality of your sensor also plays a critical role.